Section 9.4 is on rotations. So we're still talking about transformations, and so far we've done translations and reflections, and this will be rotations. So when we do a rotation, we're going to have a rotation about a fixed point. That fixed point is called the center of rotation. We can either go counterclockwise or clockwise, and the easiest rotations are always through the origin, but they don't have to be through the origin. So here we have a triangle in the first quadrant, and if I'm asked to do a rotation, it's easiest to take one line and talk about that through the point, and then now as we move the object through the center of rotation, this one is a 90 degree. This would be rotation of 90 degrees. All right. This is a 90 degrees counterclockwise, and most of the time we would consider this a positive rotation. The origin is our center of rotation. All right, now these are lots of rules, and I'm going to show you what these rules mean on the next couple of slides. Basically, we call it a clockwise rotation is going to be less than 0, so that's going to be negative. And a counterclockwise rotation is going to be greater than 0, and that means positive. So when we move counterclockwise, we say that's positive rotation, and when we move clockwise, we say that's a negative rotation. All right. If we rotate 90 degrees, what's going to happen if you could picture the object starting in the first quadrant? If you rotate it 90 degrees, then the value for the x value is going to end up being the opposite, and the a and the x and the y value are going to swap spots. If you're going to rotate 180 degrees, the values stay the same, but the signs change. If you started in the first quadrant, you would end up with an object in the third quadrant. So objects in the first quadrant are positive, and object that moved 180 degrees from the first quadrant to the third quadrant would turn out negative. Now this is also going to be true whether we're starting in the first quadrant or not, because if we started in the third quadrant and we rotated 180 degrees, we'd end up in the first quadrant, and our signs would be opposite of where they started. If you go 270 degrees, you basically, again, are going to switch the x and y values, and the sign of the original x value becomes opposite as the new y value. Because of these ideas, we can use the concept of the identity matrix, again, to multiply a point and get it into the right spot. So for me, what I think about is the 180 degree rotation. Basically in the 180 degree rotation, the x's and y's stay in the same position as they originally started. They just change signs. And so you can see that over here. That means they're going to stay in the same position and just change signs. A 360 degree rotation puts you back to where you started. And so a 360 degree rotation has the identity matrix as its matrix that's going to work. Notice when you're going 90 degrees and 270 degrees, notice that instead of being in the identity spot, the x's and y's flip, and the x changes signs. That's why that's there, because the x changes signs and they're flipping. So that's what those things are meaning.